Welcome back, Year 9. This exercise today is gradient and direct proportion, exercise 4E out of your textbook. We've seen these sorts of things before. Maybe some of the terminology will be new, but the maths won't be particularly new for you. And in fact, it's just an easy, simplified version of sketching straight lines, which is great because we've already been doing that a little bit this term. So, when things are directly proportional, if A is directly proportional to B, one thing we need, they don't do it in this book, but they do often use this. This little Greek symbol alpha is usually used to describe proportionality. So this would be read as A is proportional to B. And you could say directly proportional because B is not B squared or 1 over B or something, so they might say directly proportional. If they say inversely proportional, which we won't do, but just a heads up, if I wrote 1 over B, that's the multiplicative inverse of B. The opposite of multiplying by B is to multiply by 1 over B. That would be inversely proportional. But direct proportion is what we're dealing with today, and direct proportion just means as one value gets bigger, the other one also increases, and there's some sort of proportion, some sort of ratio between the two terms that remains constant. So whenever you see two variables being directly proportional, A varies or is proportional with B, we can always write that A is some constant multiple of B. So A equals some constant multiple of B. Now we're dealing with mostly equations, and rather than using A and B, we often use X and Y. So that's what you're going to see over here. They're going to have Y equals some multiple of X. Now they've used M because when we're dealing with X and Y and we're plotting on axes, this proportionality constant, the K that I had before, M is the gradient. The gradient of a line is equal to the rate, the proportionality rate. So that's what they've just made a point of there. So really, all we're doing is sketching straight lines where the y-intercept is 0. That's all this exercise is about. So you're going to find it fairly easy. Let's have a look here. Water is poured into an empty tank at a constant rate, and it takes 3 hours to fill the tank with 6,000 litres. What is the rate at which water is poured into the tank? So the difference between a ratio and a rate, ratio is a proportion of values measured in the same units. Rates are ratios of values in different units. The rate at which water is poured into the tank, well, I would say it's 6,000 litres for every 3 hours. Now, if I simplify those units, 6,000 divided by 3 is going to be 2,000. And usually we write out units as litres per hour, don't we? Or we could write litres and then h to the negative 1, because a negative power is the same as dividing by it. But litres per hour is fine. So the rate, you just take the amount divided by how long it took. There's my rate, litres per hour. 6,000 divided by 3 is 2,000 litres per hour. If I wanted to draw a graph of the volume versus time, volume is here, time going across the bottom, and this is in hours, and my volume is in litres. 2,000, 4,000, 6,000. That was 1, 2, 3 hours worth. Oh, jumping the gun there. 1, 2, 3. And what we'll find is, especially if I could draw to scale, they're going to follow a nice straight line. I'm allowed to join these points up because it wasn't like we just dumped in 2,000 litres every hour. It was filling up at a constant rate. If I could draw more accurately, that would look perfectly symmetrical. I don't need to go further than there because we know that the tank is full after 3 hours, so there's no arrow sticking on the end of this. But that's how you draw it. The gradient of your graph, well, we already figured that out. It's 2,000. How did I know that? Well, I could look at the rise over run and do it again. But we know that the rate is equal to the gradient. So the 2,000 that I had before is equal to the gradient. That last 0 just doesn't want to behave. I'm going to try and fix it up. We'll probably just entertain you in my struggles with my stylus. But there we go. The rule for the volume. So the volume equals 2,000. That was my rate. multiplied by the number of hours. Find the volume after 1.5. So what I do here, V, if I put in brackets 1.5 after it, that's saying find the volume when the variable is 1.5. This is going to be 2,000, and where there used to be a variable, I put 1.5, and that's going to be 3,000 litres. You could have also said, well, 1.5 is half of 3 hours, so of course it was half full. How long does it take to fill 5,000 litres? Well, this time I have to let the volume equal 5,000. 5,000 equals 2,000 times T. I divide by 5,000, I've got 5 over 2 equals T. So 5 over 2 hours, 2.5 hours. You get the idea there. There's an example there for you to try. Why don't you have a go at that by pausing the video, and then you can come back and see whether we agree. So pause the video now. Okay, hopefully you did that. Most of you are probably just watching on. I know that you do that, but it's really much better off if you could pause it and try it yourself. So go back and pause it and try it yourself now, and then join me and we'll go through it. Okay, maybe a couple more of you did the right thing there. On a long-distance journey, a car travels 450 kilometres in 5 hours. We're going to assume that it's travelling at a constant rate, because it says, what is the rate of change of distance over time? Well, it's 450 kilometres in 5 hours. So this is actually an average rate of change. They didn't say that. And they didn't say that it was travelling at a constant rate. We'll have to assume that. 450 divided by 5, that's 90 kilometres per hour. Draw a distance time graph for the first 5 hours. 1, 2, 3, 4, 5. 100, 200, 300, 400, 500, 450. And 5, let's get approximately right. Of course, you used a ruler when you did this, so yours is going to look much prettier than mine. Distance in kilometres, time in hours. Make sure I've shown everything. If I even want to dot across, I can there, just to make it clearer, but that's okay. I assume you've all managed to do that without any problems at all. The gradient of your graph, we already know that. 90. What's my rule for the distance? Distance equals 90 times the number of hours. D part 1. Find the distance when the time equals 3.5. So I've just got to go 90, multiply it by 3.5. 370 plus 45 is 315. And that's kilometres. And you could also, if you'd sketched it really accurately on graph paper, you could go up here and then sketch across and see that that was at about 315. The time to travel 135 kilometres. 135 equals 90 multiplied by t. 135 over 90 equals t. You're as good at your 45 times table as anyone could be. 45 goes into the top 3 times and into the bottom 2. So 3 over 2 hours is the time. And you could write a nice little statement. It takes 1.5 hours to travel 135 kilometres. That's what's involved in this exercise today. Again, the questions are there set for you. Sketching straight lines where the y-intercept is 0. Nice, easy topic for you today. Gradient and direct proportion. I hope that helps. Good luck with your work, and I'll be available to help anyone who's got any questions. Keep up your great work, guys. Bye for now.